Hello, I'm Sangeeta and today we are going to study about intermolecular forces. So when we talk about the intermolecular forces, we are actually dealing with the binding force which hold the molecules together and are responsible for the three states of matter, that is solid, liquid and gas. So in case of the solid, the intermolecular force of attraction is very high. So the molecules are very tightly attached to each other. Whereas in case of the liquid, the binding force is relatively lesser. So the molecules will be slightly apart from each other. Whereas in the gaseous stage, the molecules occupy almost the entire space which is available to them. The intermolecular force of attraction is least in case of gaseous particle. So we can broadly classify the intermolecular force of attraction depending upon the strength into the strong and the weak intermolecular force of attraction. So when we are talking about strong, we are talking about the electrostatic force of attraction, that is the ionic bonding. Other example is of covalent bonds. And when we talk about the weak intermolecular force of attraction, it comes under van der Waals forces. When we compare their bond energy, the bond energy is approximately 200 kilojoule per mole for the strong one, and it is approximately 40 kilojoule per mole for the weak one. So we can study the weak intermolecular force of attraction, that is the van der Waals forces, under four heads. First one is London force, which is also called as the dispersion force. It occurs between two non-polar molecules. Dipole-dipole interaction is between two polar molecules which are already having their charge separation, and dipole-induced dipole is between one polar and one non-polar molecules. And then hydrogen bonding is again a special kind of dipole-dipole forces only, so we can say that this is again between two polar molecules. So let's start, we'll study them one by one. Force is the weakest intermolecular force. It occurs when there is even distribution of electrons, right? When two non-polar atoms come close together, so it may happen that the oppositely charged particles of neighboring atom come under influence. And this happens only for a few seconds, so that is why we call it this is a temporary attraction. Then again there is a redistribution of the charge and they keep on moving. So this polarization will be for a short duration. So in this case, the positive charge of one atom come under the influence of another atom and is causing the polarization of another atom. Right? Polarization means distortion. Distortion, so that the oppositely charged particles come close to each other, and this is only for a few seconds, instantaneous. So that is why we call it that this dispersion force or the London force is a temporary. And so next is dipole-dipole interaction. This occurs between molecules which are already having their permanent dipole, means there is permanent charge separation. If we take example, we can say hydrogen and fluoride. So in case of hydrogen fluoride, fluorine is partially negative because of the more electronegative in nature, and hydrogen will be partial positive. So this negative charge of the fluorine will be attracting positive charge of hydrogen atom of neighboring hydrogen fluoride. So this interaction is called as dipole-dipole interaction. So you can consider this molecules as hydrogen fluoride. So this will be fluorine being negatively charged and this will be hydrogen positively charged. Now neighboring atom fluorine and hydrogen. So this is hydrogen fluoride. Another example for dipole-dipole interaction can be seen in chlorofluoride. So in case of this, fluorine being more electronegative will have partial negative charge, will try to attract the partial positive charge of chlorine atom, and this interaction is called as the dipole-dipole interaction. Next is dipole-induced dipole forces. This is between our molecules which is having dipole moment, that is apolar molecules, and a molecules which is a non-polar, means there is an equal distribution of charge in that. So the one which is having a permanent dipole will try to induce a dipole moment on a molecule in which there is a symmetrical distribution of charges. With the help of water molecules in which already there is a permanent dipole moment, oxygen is having partial negative charge and hydrogen atoms are having partial positive charges. This negative charge of oxygen will try to attract oppositely charged particles of oxygen molecules, resulting in the deviation of oxygen molecules. This is called as polarizability. And the last one is hydrogen bonding, and this bonding is a special type of dipole-dipole interaction only, but it occurs only in few highly electronegative atoms, that is between oxygen and hydrogen, fluorine and hydrogen, nitrogen and hydrogen. So you can learn it like NOF kind of thing. So NOF, which is only nitrogen, oxygen, fluorine, are able to form hydrogen bonding because of their high electronegativity and small size. Now hydrogen bonding is very important in our day-to-day life. We can see this in DNA as well as in protein within the living organism. Just you can see from here, this is nitrogen and hydrogen bonding, nitrogen hydrogen bonding, oxygen and hydrogen bonding, and just see from this intermolecular hydrogen bonding. You can see it from here also, intermolecular hydrogen bonding. So this is a strong bonding. Here recap, in this session we have studied about the dispersion, which is a weak London force. Then it was between non-polar molecules, two non-polar molecules. Then comes dipole-dipole, it was present in the polar molecules. Then dipole-induced dipole forces, it was present in the polar and non-polar molecules. And the last was hydrogen bonding. So this was all about it.